So when balancing equations, the conservation of matter states that we need an equal number of atoms on the left side as we do on the right side, or before the reaction as in after the reaction. So to do that, we cannot change our subscripts at all, but we can change the coefficients. And when you don't see a coefficient in front of a atom, it is assumed to be 1. So for each of these, I'm going to put in a 1 for now, which is not balanced, but we'll be balancing it as we go. So let's load the carbon far left here. We have 1 carbon here. Well, let's see what we got on right. We have also 1 carbon. So that's already balanced. We don't have to do anything. So next, let's load the hydrogen. We have 4 hydrogen because 4 times 1. Here, we have 1 hydrogen. So we need to make that 4. So this coefficient, change that to a 4. Now, let's load our chlorine. We have 2 times 1 chlorine, which is 2, on this side. On this side, we have 4 times 1 on this side. And then we also have 4 times 1 chlorine here. So we have 4 plus 4, which is 8. So that means we need 8 chlorine on the left side. But we have a subscript of 2, so coefficient only has to be 4. Because 4 times 2 is 8, and then 4 times 1 plus 4 times 1. So now you want to make sure to go back to your initial atom or element that you checked, which for us was carbon. So this is 1, and this is 1, so we're still fine. Hydrogen, we have 4, and we have 4, so we're still fine there. And chlorine, we have 8, and we already know we have 8. So we're fine there. You always want to make sure to go back and check to make sure all of it is balanced at the very end. And if any of these coefficients are divisible by a single number, you can divide all of them to be the lowest common factor.